Well, Janelle, is there a way to share the paired programming thing that we've just done through GitHub as builders who are working?
You could, but if you were pair programming, you're sitting next to each other. So it would be more appropriate to do something with screen sharing. Yeah. Like you could use a Google Hangout meetup or something like that, or there's all kinds of screen sharing programs out there, so that's what you would use. All right, let's talk about Ruby hashes. And to talk about hashes, we also need to talk about Ruby symbols. Ruby symbols are kind of a weird thing, okay? And we're not going to go into tremendous detail about them because it might get confusing. We're just going to talk about them right now in the context of how they're used in hashes. And then when we talk about classes next week, we'll talk about how they're used to define class instance variable accessors, okay? So in this unit, we're going to look at what a hash is, when they're useful, the syntax for them, and some methods that operate on them. So first, what is a hash? A hash is a list data structure like an array, but each value has a key. Each key must be unique. A hash contains key value pairs, and the values can be accessed using the keys. You can think of a hash as a dictionary. Okay? So that's what a hash is. Now in Ruby, so I said each key must be unique. In Ruby, if you try to create a second entry with a key that already exists, it will overwrite what's currently stored by that key in the hash. That's what Ruby will do. Okay? So when are they useful? A lot of times we want to store a list of data with properties. And while we could shove that into an array, it would be really messy. The code to access it, to validate that we have what we think we do, to force the input to go into that array, and the structure that we're putting on it, all of that gets to be really messy, hard to maintain, hard to understand, full of bugs. So anytime that we're dealing with data that we're trying to store in a list, and that data has properties, then we should use a hash. Okay? Now when we talk about classes, I'm going to tell you should use a class. But until we get there, we're going to learn how to use hashes, because sometimes hashes are useful. Now, the reason that I would say go right to a class is because in Ruby, classes are very easy to use. Ruby, by its nature, fundamentally is an object-oriented language. And so it makes the use of classes, the definition of them, using them super easy. So in a language like Ruby, I would choose to use classes for anything that has more than 2 properties, probably, okay? Just because the code will be cleaner, easier to refactor, to add features to maintain. But we're going to learn how to use hashes today, and we're going to save classes for next week, okay? So here's some examples of where we might use a hash. If we have a dictionary, for example, a dictionary stores a definition for each word. So in the case of a dictionary, the word is the key, and the definition is the value that we access with that key. Another example is, say we want to represent people. So if we have a person, depending on our application, we might want to know different pieces of data about a person. We might want to know their name, or their birth month and birth year if we were going to create a birthday calendar, for example. We'd want to store that information about our person. So depending on the application, that will dictate what pieces of data we need to store. But in the case where we're dealing with some object, like a person, and that object, we care about multiple pieces of data for that object, then we'd want to use a hash. If we only care about the person's name, there's no need for a hash. We would just use an array of names. Does that make sense? If we only care about storing the name and operating on the name, then we just use an array. But as soon as we need a second piece of data, as soon as we care about name and something else, you don't want to use an array. You might use an array of hashes, but you're going to use a hash to represent a single person rather than just storing that information about a person directly in an array. So, here's my little people. Say, for example, we have this set of people. We may want to use an array to store information about a group of people, but that array is going to consist of hashes. not strings. Okay? Where a hash for each person would include those 3 pieces of data in this example. We're storing their name, first name, their year of birth, and their favorite color. Who knows why we're storing this data? Maybe we're going to make a quilt or something for our representing our grandchildren. I don't know. Maybe we want to know the year they were, we want to have the year they were born, their favorite color, and that's going to be the predominant color for the quilt square. I'm just making stuff up. But for whatever reason, these are the 3 pieces of data we want to store. Each person would be represented by a hash data structure, and then we could have an array of those hash data structures. So what's the syntax for a hash? Instead of square brackets, like we use for an array, we use curly braces for a hash. And that's how Ruby knows that what we're defining for it is a hash. Okay? So the key is specified. Following the key, I call that the rocket. It's an equals and a greater than. Okay? And I call that the rocket. So it's the key, a rocket, and the value. The elements of a hash, just like the elements of an array, are comma separated. So this looks a lot like an array, except that each element of a hash is a key value pair. The key in a hash is typically a string or a symbol, but it could be anything. Now for me, total anarchy, if you're using objects as keys, that's definitely a case you should be using class structures and not a hash, but Ruby will let you do whatever you want. You can put anything can be a key. Any kind of object can be a key in Ruby. It doesn't care. But what you're going to see out in the wild is that when a hash is used, the key most likely is a symbol, and sometimes it might be a string, sometimes it might be a number, sometimes that's appropriate. Okay? The thing is that whatever the unique piece of information is, that's what the key is going to be. Okay? So, in our example that we were looking at back in the slide before, the key would be the name of the attribute for the person. Okay? So we'd have a name key, and a birth year key, and a favorite color key. So each one of those keys is unique. A person's not going to have 2 first names, and they're not going to have 2 birth years. They might have 2 favorite colors, but let's just say you can only have 1 favorite color. What's your favorite? That's your favorite color. Okay? The data doesn't have to be unique. So for example, 2 people could have the same birth year. 2 people could have the same favorite color, right? So the values don't have to be unique, but the keys have to be unique. Now, what is a symbol? A symbol is a special Ruby data type that is most similar to a string. If we were going to compare it to something else in Ruby, we'd say a symbol is like a string, but the syntax for declaring a symbol is different. A symbol isn't quoted. A symbol is preceded with a colon. Okay? So one reason that symbols are used as hash keys is because they allow for nicer syntax. When we use symbols as hash keys, this is what our syntax looks like at the bottom. So we have key, colon, value. And that looks a lot nicer, especially to somebody who's a programmer, because this looks a lot like JSON, the JavaScript object notation. And when you're a programmer, especially when you're a web app programmer, you'll be super familiar with JavaScript, like you will be when we end this course. You'll use JSON all the time. So when you see this format, it feels much more familiar. So here's our example person hash. If we make the keys strings, we could represent Charles. There's Charles. His favorite color is green. That's why it's what he's wearing. And we could represent Charles like this. So we have name, and it's a string. And we use the arrow, the rocket notation. And then we have his name is Charles. And then the second element is birth year. And that's 1990, and his favorite color. And that's green. If we use symbols for keys, then the syntax looks like what we have in the second example. Any questions so far? So if we wanted to represent all 4 of our little people here, then we could do it in an array. And it would be an array of hashes. So each person is represented by a hash where we have a key for their name, birth year, and favorite color, and the values that are appropriate for that person. So we had Charles. Zoe's born in 2003 and her favorite color is red. Frank was born in 1998 and his favorite color is blue. And then Ellen was born in 1975 and her favorite color is yellow. Now, don't get overwhelmed, but you can also store hashes and hashes, or arrays and hashes, not just hashes and arrays. And you can nest this as much as you want to, up to an extent. There will be a limit, but the limit's going to be huge. It'll be bigger than anything you ever use. So for example, let's say that we wanted to add an attribute to our person called friends. And this friend attribute, we have a name, and that's it. So we represent friends with a name. Then we could have an array of friends with names for each one. Now, it might make more sense to just use an array there, and I would accept that argument. It would probably be better to have an example where we have 2 attributes for each person, or maybe we have all 3. Okay? But you can do any kind of data structure you want, and then here you just have to be really careful about your syntax, where the curly braces are, and where the square brackets are. So we have these 3 hashes are inside of this array called friends, and this array called friends is inside of an array, a hash, where we have name and friends as the 2 elements of that hash.
In VS Code, you can, if you have enter after each one of those lines, then you can minimize those hashes so they disappear, so you can clean up your code really quickly.
Oh, really?
Yeah,
Okay.
yeah.
All right. So let's look at some useful hash methods to give us information about what's in the hash, to navigate through the hash. So let's say we have our person Charles, and we could use a method called hasKey. Now, I want you to, so what do you think hasKey does? First of all, what's its return type?
True.
Yeah, and how do we know that it's Boolean? Because there's a question mark. So what do you think, when do you think this returns true? So this first line, we're not even actually telling
If
it
the
Charles.
person has a value in name.
What this checks is there a key in this hash person? Is there a key name? Now notice the syntax here, because what type of object is name? Like here.
Symbol.
It's a symbol. And when I use a symbol in a hash, I put the colon after it. And really that's a shorthand for something else. Okay? It's a shorthand for see, now you can see all the answers though. We can't do that. I'll show you in here. Okay. Okay, so I can say person equals name Charles, birth year 1990, fave color green. That's one way I could write it. I could also write it like this. Person equals name Charles, birth year 1990, fave color green. Okay, so I could write it with symbols using the rocket notation, but in Ruby there's a shorthand because Ruby loves shorthands. Shorthand replacement. So we can just replace the rocket with the colon after the symbol instead of before. So I wanted to show you that because here on this slide, when I'm referencing this symbol, I have to put the colon in front of it. Okay? Because name is not a variable, it's a symbol. It's a symbol. If I had used strings for keys here, then I would have to reference a string here. I would put quotes around name. If I had defined the key name as a string, if I had quote name, then when I did has key, I would have to pass it a string. It would have to be quoted. But since I used a symbol, then I have to use a symbol as an argument to has key. Okay? In this case, it's true because this person hash does have a key with the symbol name. Okay? All right, what about the second one? The second one is key. Now, is this going to return a Boolean? No. There's no question mark, so it returns something else. What do you think it does?
It's just saying if the key has Charles in it.
What is it going to return? It's not going to return true or false. It'll return the key itself. So when I call the key method, I pass it a value. And it will return me the key that goes with that value if it exists. Or it will return no if that value does not exist in the hash. So this actually iterates through the hash, looking at the values, and the first one it finds that matches what we pass to it, it returns the key associated with that value. So in this case, it returns colon name. Yes?
I have a question. If
Yes.
we have like two values named same value,
Yeah.
so like Charles and another key called best mate is also Charles,
Yeah.
which one would return?
The first one.
This first one.
Yes.
Is there a way that you can make it return the second one?
No.
You can't make it ignore the first?
No. You would have to write some logic yourself that instead of using this key method, you would have to loop through yourself and find what you're looking for. So this method is sort of a convenience method, but it definitely has the caveat that it's going to return the first instance of that value it finds, the key for the first instance in that hash. Okay. All right, so what do you think this does? That looks similar to array accessing syntax, doesn't it?
Will it pull up all the information from that section that you passed?
It will give you the value associated with this key. All right? Oops. I need to fix my animation. So that's one way to do it, and this is the way that you'll see people do it. Okay? But there is also a method called fetch, which does the same thing. Right? So I've never seen people use this one. I've never seen that one in code. I always see it like that.
I think fetch is a bit old school, isn't it?
I think it is, yeah. So I put it up here because you might see it, but it's unlikely.
Does the person name, if there was Charles, and then 3 more lines of people, it'd give all 4 names, or just Charles?
I think, no, keys have to be unique. Okay? So name, this key, has to be unique in the hash.
Yeah.
There's only going to be one key called name. So it's going to return the value associated with that key. So let's look at some more methods. What about has value with a question mark? It's going to be Boolean. Yep, in this case it's going to return true because what does it do?
Decide whether there's something in that or not.
It looks at the values. So remember we looked at has key. Has key looks at the keys and sees if there's a key that matches what you passed to it. Has value looks at the values and returns true if it finds that value in the hash. What about dot length?
Is that the number of keys?
Yeah, the number of items in the hash, where an item is a key value pair. Right, so it's the number of items in the hash. You can think of it as the number of keys.
So number of keys would be the same then?
It would be the same. That's right. But this doesn't return a number. Person.keys. Can you guess what that might do?
Return the keys.
Yeah.
Name.
Yep. What it does is it returns an array of keys.
Well, I thought the other one did that there.
It returns an array of keys.
So that's 3 keys though, isn't it?
It returns the array. If you want to use it, then you'd have to store it in a variable when it returns. A lot of times what you'll see is you'll see person.keys.each. You might see something like that, but there is an alternative person.eachKey. But it returns an array. What about person.values? What do you think it does? It returns an array of values. All right, so here are some useful methods for making changes to a hash. So hash manipulation. Person.clear. What do you think that does? It empties it.
Empties the values?
Everything.
Everything.
Everything. You end up with just an empty hash. What about person.delete and we pass it a key?
These like key and value.
It does. It deletes the key and the value. It deletes both of them. What if we said person... Oh, there's a capital P. Stupid. PowerPoint likes to capitalize every time I hit enter on the page. It's so annoying. I'll fix that in a second. Person with a little p. Pretend like it has a little p. Person of favorite color equals green. What would that do?
Override the favorite color.
That's right.
Or if there's not one there, would it add it?
Yes. Yes. What about that one? The next one. The same thing, right? It's going to change what's currently stored with that key to a new value. So if we want to change a value associated with a key, then we can use that notation. If we want to add a new key value pair, we use the same notation. All right, iteration. Person.each. What do you think that does? Yeah, it iterates over the key value pair. Okay, we'll look at syntax in a minute for what it looks like to be able to use that iteration. Whereas, what do you think person.eachKey does? Just iterates over the keys, and each value just iterates over the values. Okay? So let's look at what this looks like. So if we use each, then in our pipes, we have to refer to the key and the value. What it actually does is it generates an array for each element, where the 0th element is the key, and the first element is the value. But we can destructure that array by referring to both the key and the value. And this is the way you'll see it done. Okay? So if I have, why would I do this? If I want to have a handle on, if I want to use or access both the key and the value for each element in my hash, I would use each. I refer to key and value when I declare my variables in that loop, and then I can access both the key and the value. Okay? If I'm only interested in the key, I don't need the value for this purpose. If I'm only interested in the key, then I would use each key. Each key is going to store the key in the variable over each iteration. Similarly, if I only care about the values and I don't need the keys, then each value is going to store the value for each element of the hash in the variable I specify with each iteration of the loop. Okay? Most typically, you want both the key and the value, but there could be times where you're just trying to see, does my hash contain this particular key, or maybe not this, that you could use a simpler method for that unless you want to control the loop yourself. Maybe I just want to manipulate the keys or print the keys or, something like that, then I might use each key. But most of the time when I'm using a hash iteration, I just use each because typically you want the key and the value to do something with them.
It sometimes gets confusing when you're writing for each value and value, and then you've got two different value variables in there. Like you're just writing the variable over and over again sometimes. You know what I mean? Like.
Yeah, so you're talking about my naming choice for the variable? Yeah, so it's probably like programmers will usually use single letter.
And then
single letter like K and V. It's important what's important is that you understand that variable name in the pipes is whatever you want it to be, and it should be clear to you and other people what it stands for. It is acceptable and accepted to use a single letter to represent a variable in an iteration or a loop. It's a very common practice that programmers will do that. They'll use just V or just K, okay? And that's totally fine, or just I for index.
But if you're doing a pair programming thing or you're sharing a code with someone else, having something very specific to what it does is also very helpful so they can read your code without too much commenting and understand what's going on.
Yeah, and for those who can attend on Friday night, Matthew Puku, who's in the Fast Track course, he's going to do a presentation on the benefits of naming your variables and methods and so forth in a way that makes your code read like English, and how it helps to keep you from introducing bugs, and how it makes it really easy to maintain your code. I think it's going to be a really good presentation. So if you are able to go to that, you'll get to hear him. Do you have a question, Aiden?
Sir, I haven't seen the variable being named in type before. I've never seen it. I didn't know what it was till the time. Does it actually contain anything?
So what happens is every time through this loop, okay, so this is a looping method, right, an iteration method. So the first time through, it's going to store the key for that first element. So it's going to store the symbol name and key, and it's going to store Charles and value. The second time through, it's going to store birth year and key, and 1990 and value. And the third time through, it'll store fave color and key, and green and value.
So that'll print out 3 lines. It'll print out key equals name,
Yeah.
value equals Charles.
Let's have a look at it. What did I forget? What did I forget? Yeah, look, it doesn't like, oh, because I copied it from PowerPoint. God damn it. Okay, this is what I'm going to do. So this is what a programmer does, so they can avoid that. This should have gotten rid. Oh, maybe it didn't though. Let me see. I don't know if that'll work or not. Let's just try as an experiment. Oh, it still didn't. Oh, it's so annoying. PowerPoint is putting some weird invisible symbols. Can somebody see something else that's wrong with it? Because I think it's PowerPoint's. Because this happened the other day, remember? Yeah.
It's the quotes.
Oh, yeah. No, is it? Why is it the quotes? What quotes?
Because PowerPoint changes it to smart quotes. Which quotes everything.
Yes. Okay. Okay, let's try this. Oh, it does. How do you even... What are those quotes on my keyboard? Do they exist?
Can you copy it? There, and then replace it.
Yeah, let's try that. Alright, so it'll print out key, name, value, Charles. Now, key birth year, value 1990. Notice when it prints the symbol, it doesn't print it with the colon, but it doesn't print it with quotes either. So that's just something to notice when you print a symbol with puts. Okay. And if we do the one with keys, so if we do each key, then we'll only have key, then it just prints the key. And with value, it just prints the value. So it's just like an array, each iterator. It does exactly the same thing. Okay, but in this case we have key value pairs, so we have to account for that. Alright, so that's it. Hashes are lists with key value pairs. Keys can be any type, but they're usually strings or symbols, and most commonly they're symbols. They can be nested in arrays or other hashes. Arrays can be nested in hashes too. It's a crazy world out there. There are many methods, and I only showed you some of them. Okay? So don't be afraid to go look at the Ruby docs, which I have linked here in the PowerPoint, to have a look at what other methods are there that you can use. So if we have a look at what's in Canvas, so the hashes method, the hashes unit is below the methods unit. We'll talk about methods on Monday, okay? So skip over that one for the moment. Look at the Canvas challenge for hashes. So there's a little bit of description there. And then there's a challenge. So here's a different person object. It's got some different information in it. Name, height, and weight. And what we want to do is we want to add John's occupation and hobbies to that hash, delete his weight, get his height, and iterate through the hash so we can see all of John's details. So you can use the methods that are in that slide deck to do all those things. Okay? Beast mode, you have a group of friends that just finished lunch, write an app to work out how much each person owes. So it gives you a description of what to do here. So if you get through this basic challenge really quickly and it all makes sense and you feel comfortable with it, then go on and try the Beast mode. And then there is a Beast mode plus plus. as well, okay? So if you don't feel comfortable doing this basic challenge, then let me know, okay? And or you can send me a Slack if you want to, whatever, and then maybe we can do just a smaller review session this afternoon, say around 2 o'clock. So we'll break for lunch now. We'll come back at 1, work on the challenge in Canvas. If after an hour you're like stuck and it's not making sense, let me know, and we'll get together in the back of the classroom in a smaller group, and I'll go over whatever's still confusing, okay? Sound good? All right, cool. Thanks, guys.